Assalamualaikum and a very good morning to you, madam. We are group number 4 and today we will be showing you our play. But before we begin, let us introduce ourselves. My name is Khairun Batisha binti Mazlan.
My name is Keshika.
My name is Jasrina.
My name is Intan Naurana Suha.
My name is Kishaf.
My name is Irfan.
And with all that said, our roleplay scenario is the Harmonia Music Festival. Since there are 6 of us, we'll take on multiple roles. We'll be taking on the roles like the event planning team, the artists that will be performing at the festival, or we'll just be attendees enjoying the festival. Throughout this event, we'll be applying key mathematical concepts from permutation and combination, probability and tree diagrams to solve real-world challenges like scheduling performances, managing ticket sales, and organizing a lucky draw. By doing so, we'll be showing how math plays a crucial role in decision-making for event planning. With all that said, let's begin.
We have a problem. The festival is going to start in 3 more minutes and we still don't even have a final lineup for these 3 amazing artists, Khairun, Nas and Keshika. Let's decide first what we do. Okay guys, who wants to go first?
I want to start. I'll get the crowd excited.
Good choice.
Now, we should go second.
Right, so now we have a final lineup.
Keshika, Nas and last is Khairun. Are we okay with this?
Is there any changes?
I don't want to perform after Keshika.
Okay, let's finalize this now. So is everyone okay with this lineup?
So in this kind of scenario, we can use permutation to solve our problem. So in this case, the example is we can use 3 factorial, which is this.
Ladies and gentlemen, welcome to NAS Lucky Draw event. Today we have 10 amazing participants, but only 3 lucky winners will get the prize.
I have a good feeling about this. I never win anything, but maybe today is my lucky day.
Just give me the prize.
Alright, let's get started. We have 10 participants and we are picking 3 winners. The number of ways we can choose them is calculated using combinations. Who can tell me how many ways we can do?
Well, since there is no particular order for us to choose the winners, we use the combination formula NCR. So there are about 120 ways for us to choose our winners.
Okay, let's get started. So the number is number 1, 6 and 8.
No, I was so close. Okay, alright team, we have 3 enthusiastic applicants, which is Khairun, Intan and also Keshaf. But we can only pick 2. How should we do it?
So let's make it fair and random. We can either draw names from a box, or use a number system with a dice, or an online generator.
I'm agree, but first, let's list all the possible groups of 2.
In this scenario, we have 3 applicants, P1, P2 and P3, but we can only choose 2 as the volunteers. Since the selection does not consider order, choosing P1 and P2 is the same as choosing P2 and P1. This is a combination problem. So, the formula for combination is n factorial over r factorial, open bracket, n minus r, close bracket, factorial. This equals to 3 factorial over 2 factorial, open bracket, 3 minus 2, close bracket, factorial, which will equals to 3. Therefore, there are 3 different ways to select the volunteers. Thank you.
Alright, let's do our selection.
Okay, first name, Intan. Second name, Khairun.
Awesome. So our volunteers are Intan and Khairun.
Now, for this challenge, how many ways can we rank them as first and second?
That's the combination problem. Since we have 2 people and we are arranging them in an order.
So, there are 2 ways to rank them.
This was fun.
Now, let's inform our selected volunteers.
And let's thank Keshaf for volunteering too. Maybe he can help in a different way.
Alright,
I think the Harmonia Music Festival is just around the corner and we need to finalize the ticketing arrangement. Based on previous festival, we know that 70% of attendees buy their tickets online while 30% purchase at the entrance. We are expecting 500 attendees this year.
That's right, but here's the question. We randomly select 3 people from the crowd. What's the probability that at least 2 of them bought their ticket online? This will help us to decide whether we should focus more on online ticketing promotions or prepare for a large crowd at the entrance booth.
Good question. Since each attendee has a 70% chance of buying online and a 30% chance of buying at the entrance, this is a binomial probability problem. Let's define we need to calculate Px equals 2 or more than 2, which means either exactly 2 or exactly 3 people bought their tickets online. Using the binomial formula, Px equals to k equals to bracket n k bracket, which is actually the binomial coefficient of n factorial over k factorial bracket n minus k bracket factorial times p power of k times q power of bracket n minus k. First, let us find Px equals to 2. So you just replace k with 2, and after calculating everything, you should get your answer as 0.441. Meanwhile, for Px equals to 3, you replace k with 3, and you should get the answer 0.343. Adding them together, Px equals 2 or more than 2, 0.441 plus 0.343, you should get the answer 0.784. So the probability that at least 2 out of 3 randomly selected people bought their tickets online is 0.784 or 78.4%.
Wow, that's a high probability. That means nearly 80% of the time, at least 2 out of 3 people in line already have their tickets. We should definitely focus on making the online ticketing system more efficient and encourage people to buy in advance.
We also reduce the number of entrance booths to cut costs and avoid unnecessary long lines. This analysis really helps us make smarter decisions.
Plus, this means the lucky draw event can be optimized too. Since most people buy online, we can use their ticket ID numbers for a fair and quick selection process.
This is a perfect example of how probability and statistics helps us make real-world decisions. Thanks to these calculations, we now know how to manage ticketing and ensure a smooth event.
I'm hungry. Should I go to Vendor A or Vendor B? Hey, come. Yes, come. I have everything. I have vegetarian, I have chicken, I have beef meals.
I also have the same option, but a lot cheaper.
If like that, let's start with 3 and you see all of the meal choices.
This tree diagram represents a probability problem involving 2 vendors, which is vendor A and vendor B, who sell 3 types of meals: vegetarian, chicken and beef, each with an equal probability of being chosen. The first branch is choosing a vendor. There are 2 vendors, vendor A and vendor B. The probability of choosing vendor A is 0.6 and the probability of choosing vendor B is 0.4. Second branch, choosing a meal. Each vendor offers 3 types of meals, which is vegetarian, chicken and beef. The probability of choosing each type of meal, vegetarian, chicken or beef, is 1/3 for both vendors. Probability of selecting beef from vendor B. Probability of choosing vendor B is 0.4. Probability of choosing beef from vendor B is 1/3. So the total probability is 0.4 times 1/3, which equals to 2/15. Similar calculations for chicken and vegetarian from vendor B. Probability of chicken is equals to 0.4 times 1/3 equals to 2/15. Same goes to the probability of vegetarian. The general probability calculation is the probability of selecting a meal from vendor A and any specific type is computed similarly. Vegetarian from vendor A is 0.6 times 1/3, which goes to chicken and also beef. The conclusion is this tree diagram helps visualize the probability of selecting a particular meal from either vendor. It confirms that the sum of all probabilities equals to 1, ensuring the calculations are correct.
Through this roleplay, we demonstrated how mathematical concepts like permutation, combination, probability, and tree diagrams are essential in real-life decision-making. From organizing a last-minute artist lineup using permutation to conducting a lucky draw with combination, we explored how different counting techniques apply depending on whether order matters. Choosing volunteers further reinforced the distinction between permutation and combination, while our probability question on ticket purchases highlighted real-world statistical analysis. Lastly, the tree diagram provided a structured way to visualize meal choices at the festival. This activity not only strengthened our understanding of these concepts, but also improved our problem-solving, teamwork, and analytical skills. By applying mathematics to a practical and engaging scenario, we gain a deeper appreciation for its relevance beyond the classroom. Thank you for listening.